Hey guys, so what we're going to look at today is we're going to look at alpha decay. Now, alpha decay is when a nucleus emits 2 protons and 2 neutrons joined together. We're going to do some practice on decay equations and balancing decay equations involving alpha decay. So let's first start off. We have an atom that is very unstable. Okay, so we have an atom that is really unstable, and it is uranium-235. Now, uranium-235, the 235 means that it has 235 protons and neutrons together. Okay, it has 92 protons because that's what makes a uranium element a uranium element. It's very unstable because it has too many neutrons. So what it's going to do is it's going to give off an alpha particle like this to make it a little bit lighter. Okay. In that process, when it gives off an alpha particle, it loses 4 neutrons and protons together. So the mass of this new element is a little bit smaller. And so this new element has a mass of 231. Okay. Now the mass of it is 231. It's also lost 2 protons, because remember, an alpha particle has 2 protons and 2 neutrons. So it has lost 2 protons as well. So that means that the new element has 90 protons. So that means that this element is something called thorium, or thorium-231. And it's thorium because thorium always has 90 protons. So I'm just going to rub this out very quickly. So that's what the decay would look like, but let's look at what it would actually look like in terms of a decay equation. So just make sure that's nice and dry. Okay, so we would start off with, classic Mr. Wrigley dropping his pen, we would start off with uranium-235, but we don't write it as U235 like we did a minute ago. What we're going to do is we're going to use Nucleon Notation, 235 like this, and we write 92 at the bottom like this. It gives off 2 things. We always write the heaviest thing first, but the first thing the uranium atom has actually given off is an alpha particle. So an alpha particle has a mass of 4, so we put the mass number up there like this, and it has a proton number of 2, so we'll write it there like so. So then we have a mystery element here. Now we know that an alpha particle was given off, so we can work out what was left over by doing 235 minus 4, which gives me 231. And the proton number is going to be 92 minus the 2 over there, so it's going to be 90. So I know what the element is by going to my periodic table and looking at what has a proton number of 90. And it's thorium. So that's how we would write the decay equation. Now, in the kind of exams that you're going to get, or the kind of questions in the exams you're going to get, one thing you might have is a question like this, where this bit is rubbed out, and you would say, okay, fill in the gap, and you would say, oh, okay, well, it's 4 and 2 because everything on both sides needs to be balanced, so it's an alpha particle. It might be the case that this is filled in a gap, or this is a gap, and it's a case of filling the numbers up. But the only thing you need to remember is that 235 here adds up to everything on this side on the top, and 92 here equals 92 here. Everything on this side, on the bottom, equals everything added up on the bottom.